Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
They are among the biggest explosions of radio energy in the entire universe. They generate more energy than 1 billion suns.
For centuries, the night sky has been a source of wonder and inspiration for humanity. Its vast expanse is dotted with stars, galaxies, and mysteries yet to be uncovered. But every so often, the cosmos gives us an extraordinary event that captures the imagination of people around the globe. Such an event is unfolding right now, as one of the most iconic stars in the night sky, Betelgeuse, has finally exploded in a supernova visible to the naked eye from Earth. This monumental cosmic event is transforming the night sky into a spectacle never before witnessed by human eyes. Betelgeuse, a massive red supergiant located in the constellation Orion, has long been a star of intrigue. Positioned roughly 642 light-years away from Earth, it is one of the brightest and largest stars observable from our planet. For decades, scientists have speculated about its eventual fate, predicting that it would end its life in a spectacular supernova. That prediction has now come true. As news spreads of Betelgeuse's explosion, astronomers and enthusiasts alike are scrambling to understand the implications of this cosmic phenomenon. What does it mean for our understanding of the universe, and how will it change our perception of the night sky? Betelgeuse's explosion was not unexpected, yet its timing has caught the scientific community by surprise. Astronomers have been monitoring the star for years, noting unusual dimming and brightening patterns in its luminosity. These fluctuations were thought to be precursors to its eventual demise, but no one could pinpoint the exact moment of its collapse. In late 2019 and early 2020, Betelgeuse experienced an unprecedented dimming event, sparking widespread speculation that the end was near. However, the star rebounded, leaving experts to wonder if they had misinterpreted the signs. Little did they know, the explosion was closer than anyone could have anticipated. The light from Betelgeuse's supernova has now reached Earth, illuminating the night sky in a way that has left observers awestruck. For the first time in recorded history, a supernova is visible in real time without the aid of telescopes. Its brilliance rivals that of the full moon, casting an eerie glow across the landscape and making it impossible to ignore. The sight is both beautiful and humbling, a stark reminder of the immense power and scale of the universe. The explosion of Betelgeuse is not just a visual spectacle. It is also a scientific gold mine. Supernovae are rare and short-lived events that provide invaluable insights into the life cycles of stars, the synthesis of heavy elements, and the dynamics of galactic evolution. When a star as massive as Betelgeuse explodes, it releases an enormous amount of energy and ejects its outer layers into space, enriching the surrounding interstellar medium with elements like carbon, oxygen, and iron. These elements are the building blocks of planets, life, and even future stars. In a way, Betelgeuse's death is a cosmic act of creation, seeding the universe with the raw materials for new beginnings. What caused Betelgeuse to explode, and why is it such a significant event? To answer these questions, we must delve into the inner workings of massive stars. Betelgeuse is a red supergiant, a late stage in the life of a massive star. At its core, nuclear fusion has been occurring for millions of years, converting lighter elements like hydrogen into heavier ones like helium, carbon, and eventually iron. Iron is the tipping point for massive stars. It cannot undergo fusion to produce energy, leading to a catastrophic imbalance between gravity and pressure. When the core collapses under its own weight, it triggers a supernova, a violent explosion that propels the star's outer layers into space. The sheer scale of this explosion is difficult to comprehend. Betelgeuse is estimated to be over 700 times the size of our Sun and nearly 20 times more massive. Its supernova has unleashed an amount of energy equivalent to billions of nuclear bombs detonating simultaneously. This energy is radiated across the electromagnetic spectrum, from gamma rays to visible light, creating the dazzling display we now see in the night sky. The explosion of Betelgeuse is more than just a cosmic fireworks display. It is an event that will leave a lasting legacy on Earth and beyond. For months to come, the night sky will be dominated by the brilliance of the supernova. Astronomers predict that Betelgeuse will remain visible even during the daytime for several weeks, and at night, it will outshine all other celestial objects except for the moon. This rare phenomenon will transform our understanding of the universe, offering scientists a once-in-a-lifetime opportunity to study a supernova as it unfolds. One of the most fascinating aspects of this explosion is the light it has produced. Traveling across 642 light-years of space, the photons from Betelgeuse's supernova have carried vital information about the star's final moments. By analyzing the spectrum of light emitted during the explosion, scientists can determine the composition of the star's outer layers, the velocity of the ejected material, and the mechanisms driving the explosion. These observations will help refine existing models of stellar evolution and provide new insights into the processes that govern the life and death of massive stars. As the shockwave from the explosion propagates through space, it will eventually interact with Betelgeuse's surrounding environment. This interaction is expected to produce dazzling displays of X-rays and radio waves, which will be closely monitored by observatories around the world. These emissions will reveal the structure of the star's outer atmosphere, the density of its surrounding gas, and the dynamics of the explosion itself. Fortunately, Betelgeuse is far enough away that its explosion poses no direct threat to our planet. The intense radiation from a supernova can be devastating to nearby planets, stripping away atmospheres and disrupting ecosystems. However, at a distance of 642 light-years, the energy reaching Earth is not sufficient to cause harm. Instead, we are left with a spectacular light show and a unique opportunity to witness one of the universe's most dramatic events. The explosion of Betelgeuse serves as a stark reminder of the cosmic forces at play in our universe. Supernovae are not uncommon, but their occurrence within our galactic neighborhood is exceedingly rare. When they do happen, they can have far-reaching consequences, influencing the formation of new stars and planets and even triggering changes in the chemical composition of galaxies. The elements ejected by Betelgeuse's explosion will eventually become part of the interstellar medium, contributing to the next generation of stars and possibly even life. For humanity, this event is a humbling reminder of our place in the cosmos. The night sky has always been a source of inspiration, and the explosion of Betelgeuse is a powerful testament to the dynamic and ever-changing nature of the universe. It is a moment that unites us all under the same celestial spectacle, reminding us that we are part of something far greater than ourselves. As the supernova continues to unfold, astronomers will be working tirelessly to capture every detail. Advanced telescopes like the James Webb Space Telescope, the Hubble Space Telescope, and ground-based observatories equipped with cutting-edge technology will be focused on Betelgeuse, capturing data in unprecedented detail. These observations will be shared with the global scientific community, ensuring that the lessons learned from this event benefit everyone. What makes this supernova even more special is its accessibility. Unlike many astronomical phenomena that require specialized equipment to observe, Betelgeuse's explosion can be seen with the naked eye. People around the world, from bustling cities to remote villages, can step outside and witness this incredible event. It is a rare opportunity for humanity to collectively marvel at the wonders of the universe, bridging divides and fostering a sense of shared curiosity. The cultural and historical significance of this event cannot be overstated. Betelgeuse has been a prominent feature of human mythology and astronomy for millennia. In ancient times, it was revered as a symbol of power and transformation, often associated with the changing seasons and the cycle of life and death. Today, its explosion marks the end of an era and the beginning of a new chapter in our understanding of the cosmos. The supernova of Betelgeuse is also sparking a renewed interest in the study of nearby stars and their life cycles. Astronomers are now turning their attention to other red supergiants, wondering which might be the next to go supernova. Stars like Antares in the constellation Scorpius and Betelgeuse's neighbor Rigel, a blue supergiant, are being carefully studied to better understand the signs leading up to these cosmic explosions. With the lessons learned from Betelgeuse, scientists are refining their ability to predict and prepare for similar events in the future. One of the most profound implications of Betelgeuse's explosion is its impact on our understanding of stellar nucleosynthesis, the process by which stars create elements. In the core of a massive star, nuclear fusion produces elements up to iron. However, elements heavier than iron, such as gold, uranium, and platinum, are forged in the extreme conditions of a supernova. By studying the remnants of Betelgeuse's explosion, scientists can gain insights into how these elements are distributed throughout the galaxy, contributing to the formation of planets and even the materials we use on Earth. The supernova also has implications for the search for extraterrestrial life. Betelgeuse's explosion is an example of how stars seed their surroundings with the elements necessary for life. Over time, the materials ejected by supernovae mix with the interstellar medium, forming the building blocks of new solar systems. Understanding this process is crucial for identifying regions of the galaxy that may be conducive to the emergence of life. It is a reminder that we owe our existence to the death of ancient stars whose remnants form the very atoms that make up our bodies. As the weeks turn into months, Betelgeuse's supernova will evolve, offering new opportunities for observation and discovery. The initial explosion, marked by a brilliant flash of light, will give way to a gradual dimming as the star's ejected material expands and cools. During this phase, astronomers will study the formation of a supernova remnant, a structure composed of the star's outer layers now scattered across space. These remnants are among the most stunning objects in the universe, often taking on intricate and colorful shapes as they interact with the surrounding medium. In addition to its scientific significance, Betelgeuse's explosion is likely to leave a cultural and artistic legacy. Throughout history, celestial events have inspired countless works of art, literature, and music. From the supernova recorded by Chinese astronomers in 1054, which gave rise to the Crab Nebula, to the Star of Bethlehem in Christian tradition, the night sky has been a canvas for human imagination. Betelgeuse's supernova is sure to inspire a new wave of creativity as people around the world seek to capture the wonder and beauty of this event. The transformation of the night sky is not only a visual spectacle but also an opportunity for education and outreach. Planetariums, observatories, and science educators are seizing the moment to engage the public, offering lectures, workshops, and observation sessions to share the wonders of Betelgeuse's explosion. This event is sparking a renewed interest in astronomy, inspiring a new generation of stargazers and scientists. For amateur astronomers, the explosion of Betelgeuse is a dream come true. Armed with nothing more than binoculars or a backyard telescope, they can participate in this historic event, contributing valuable observations to the scientific community. Citizen science initiatives are encouraging people to document the supernova, track its brightness, and share their findings. This collaborative effort is a testament to the power of science to bring people together, united by a common goal of exploration and discovery. Looking ahead, the explosion of Betelgeuse will have lasting effects on the field of astronomy. It serves as a reminder of the dynamic and ever-changing nature of the universe, challenging us to stay vigilant and curious. As we celebrate this extraordinary event, we are reminded that the cosmos is full of surprises, and there is always more to discover. Betelgeuse's supernova is a pivotal moment in humanity's journey of understanding the cosmos, but it also raises intriguing questions about our place in the universe. As we gaze at the brilliant light in the night sky, it's worth reflecting on the interconnectedness of all things. The elements forged in Betelgeuse's explosion will travel across the galaxy for millions of years, potentially becoming part of new stars, planets, or even life forms. This cosmic recycling reminds us that we are not isolated from the universe. We are intrinsically linked to its vast and ongoing story. One particularly exciting avenue of research following Betelgeuse's explosion is the study of its neutron star or potential black hole remnant. When a massive star collapses, the core that remains can become either a neutron star or, in extreme cases, a black hole. If Betelgeuse has formed a neutron star, it would be an incredibly dense object, packing the mass of the Sun into a sphere just a few miles across. If it has formed a black hole, it would be an invisible yet immensely powerful entity, warping space and time around it. Astronomers are eagerly looking for signs of the remnant. If a neutron star exists, it may emit pulses of radiation, becoming what is known as a pulsar. Detecting these pulses would provide critical information about the mass, spin, and magnetic field of the remnant. If it's a black hole, its presence may be inferred through its gravitational effects on nearby matter. Either outcome represents a treasure trove of data for scientists seeking to understand the final stages of stellar evolution. As the immediate brightness of the supernova begins to fade over the coming months, a fascinating afterglow will emerge. This afterglow is caused by the radioactive decay of elements created in the explosion, such as nickel and cobalt. The light from this decay will provide clues about the amount and distribution of these elements, further enriching our understanding of how supernovae contribute to the chemical enrichment of the universe. Betelgeuse's supernova is also likely to leave behind a stunning nebula, a cloud of gas and dust that will expand over thousands of years. This nebula will become a laboratory for studying the interaction between supernova remnants and the surrounding interstellar medium. It may also give rise to new star-forming regions, continuing the cycle of cosmic evolution. In a few million years, the descendants of Betelgeuse's explosion may light up the galaxy as new stars, perhaps with planets orbiting them. For now, however, we are witnessing the immediate aftermath of one of the most extraordinary events in the universe. The explosion of Betelgeuse has captivated the world, uniting people across continents in awe and wonder. It is a reminder of the beauty and fragility of our existence, set against the backdrop of a universe that is constantly changing, creating, and evolving. The story of Betelgeuse is far from over. In the coming years, scientists will continue to analyze data from the supernova, uncovering new insights and raising new questions. The light from the explosion will serve as a beacon for future generations, reminding them of this historic moment when humanity turned its gaze to the heavens and witnessed the death of a star. As you step outside tonight and look up at the night sky, take a moment to marvel at the brilliance of Betelgeuse's supernova. Its light has traveled for over 600 years to reach us, a journey that began long before telescopes or satellites existed. It is a cosmic gift, a reminder of the infinite wonders that await us in the vast expanse of the universe. And as the night sky glows with the light of a star's final act, we are reminded that the universe is not a distant, untouchable realm. It is a part of us, and we are a part of it.